go over example 6. We're going to use calculus to find the value for this solid, but this time it's going to rotate it about a vertical line that is not the y-axis. Example 6. We try to find the value of the solid obtained by rotating the region in last example, example 4, and we're going to rotate this region about this vertical line x equal to -1. So this is a region. It's bounded by y equal to x and y equal to x squared over here. Okay. You're going to rotate this region about this vertical line x equal to -1. So we got a solid like this. Okay, think about a solid like that. Now we try to find the value for this solid. Then we're going to slice it horizontally. So slice it horizontally. Each one is like a washer. Okay, each slide is like a washer. Okay, so for washer, it's going to be this cross-sectional area times the thickness. The thickness over here, it is going to be delta y, so dy. Okay. Now, what about this outer radius? From here all the way to this outer edge. Now, remember when you try to find this big R, the outer radius, you go from the center all the way to the outer edge of this original region, this one over here. Do not look to this side because this is a region that's bounded by the two curves. So look to this region to find this outer radius. So big R will be from here to here. Now, the center over here, the x coordinate is equal to -1. So x equal to -1. Notice that for this cross section here, the y coordinate is going to stay the same. So this point and this point both have the same y coordinate. Now, this point over here is on this y equal to x squared, this curve. So solve for x, x will be equal to square root of y. So the x coordinate for this point, if I express that in terms of y, that will be equal to square root of y. So that is square root of y. Now to find this big R here, we use the x coordinate here, subtract the x coordinate here. So that will be square root of y subtracting -1, which is the same as square root of y adding 1. Similarly, this small r, the inner radius, is from here to here. Okay, this is the center, is x equal to -1. And the other one over here, this point over here is on this straight line, y equal to x. So express this x over here in terms of y, that will be x equal to y. So the small r here is this x, subtract this x. So that will be y subtracting -1 will be this subtracting this. So that's the same as y plus 1. So that's a small r. Now you get this outer radius, big R here, to be 1 plus square root of y. And you got the small r over here to be 1 plus y. So this is the cross-sectional area. Now, when you integrate this cross-sectional area, and then this dy here, think about as the thickness of the disk. So cross-sectional area times the thickness give you the value for one slice over here. Okay, done. Y here go from 0 to 1 because the slice, the bottom one, the y will be 0, and the one at the top, y here will be equal to 1. So y go from 0 to 1. Now, integrating this ay, okay, put this over here with respect to y go from 0 to 1. Now, this part here, you expand this, use the perfect square formula. So that will be 1 plus 2 square root of y plus y. Expand this using the perfect square formula. That will be y squared adding 2y adding 1. Now do the algebra. Then we simplify and got this. Now when you try to find antiderivatives, it's better that you write each one of them in power form. So square root of y, we would write that in power form. So that will be y to the 1/2 power. So this pi here is a constant multiple, so it's outside. So there'll be antiderivative will be 2 times y to the 3/2 power and times 2 over 3. So that will be 4 over 3. So antiderivative will be this. Antiderivative y is y squared over 2. Antiderivative y squared is y cubed over 3. Now we evaluate y going from 0 to 1. Result here is pi over 2. Okay, now I want to make one remark. Okay, so students who might find this part here a little bit challenging. Okay, so I make one remark over here. So suppose this is the original region that's bounded by the two curves. And we're going to rotate this region about this vertical line x equal to 1. Then how do you find this outer radius big R? So the outer radius big R will be from here, will be the distance from here to the center here. So the center here, the x coordinate is 1. This point here, the x coordinate is x1. So we use the x coordinate for this, subtract the x coordinate over here. So that will be 1 subtracting x1. That's a big R. The small r over here is 1 subtracting the x coordinate for this point, which is x2. And the thickness of this washer over here is delta y. So later, we're going to express this x1 and x2 in terms of y later. Okay, so let's take a break.